You're listening to Within Tolerance, a podcast for machinists by machinists. I'm your host, Dylan Jackson of Proteum Machining, and this week I am rejoined by Uriel Eisen of Austere Manufacturing. Welcome, Uriel.
Thanks for having me.
My pleasure. And so, for anybody who wants his backstory, head on back to episode 109. I had him back then, but you've had quite a bit that has happened since then. I mean, I think people kind of know you as the spindle gripper guy now. So we had
Sure.
a lot of questions. Tim Strobel, Possum Solutions, Ian Porter, and Tuck's Garage. They all kind of wanted to know about the spindle gripper. How'd you come across the design for it? How'd you get into all of this, and what goes into that kind of automation? So let's break it down. Where did this whole idea start?
Yeah, we started so we manufacture small pieces they're all CNC'd aluminum buckles for soft goods, outdoor industry stuff. And yeah, they're pretty small and pretty intricate. And we were running them originally on tombstones, which were running 8 parts in op 1 and 8 parts in op 2. So every cycle it would finish 8 parts. And those were very productive for us. We had a few issues with them. One, you're really stuck in front of the machine. Two, I was literally getting tendonitis in my wrists from loosening and tightening all those little screws and like mighty bite clamps all day. And then the last problem, I mean, there are a lot, but the last big problem of running them was basically as they wore, it was very hard to adjust specific pockets. So op 1, that wasn't an issue, but our op 2 pockets, one would start to drift slightly, and you're kind of like, well, I don't want to remake the whole tombstone, but this pocket is so you end up either shipping stuff you're not super pleased with, or having to remake the whole thing, or just skip a couple pockets, and then you're starting to cut into the efficiency of the total jig. We were also using those Uniforce clamps, which the nice thing is they sort of hold 2 parts at once. The not nice thing is if one of those parts starts to drift, you still need something in that pocket to push against the other side.
Oh yeah. Well, and I've heard too that Mighty Bite hardware is kind of prone to failure. It strips out like looking at it wrong.
Yeah, we ended up helicoiling everything, and that helped a lot. And yeah, I mean, and the other piece is like the cost was pretty high of making one of those in terms of the machine time, in terms of the hardware to populate it. And those were tiny fixtures, and they didn't give us enough walkaway time. So it was really this like, they were productive. They made us good parts. We started our business using those, and but it became clear that we needed some other solution. And so we started looking at a couple options. One was sort of just larger tombstones, put more parts on a tombstone. One was sort of like a trunnion that held pallets. And the advantage of a trunnion was basically that, as you expand a tombstone, we need really a lot of tool access. And so as you expand a tombstone, the trouble is that you have bigger flats. And so the parts in the middle you can't really necessarily reach 3 sides of. Anyway, so that was the consideration. And then the way we came across the gripper, our rep from Yamazen, Peter, was in the shop, and he was like, hey, by the way, like this might be perfect for you, but we put these grippers in the tool changer, and it might work for op 1. And so that was kind of interesting. So I started researching it, and my big hesitation there, and I think a lot of folks sort of face this when looking at automation, is it's sort of like, okay, that's a cool system, but how robust is it going to be? How reliable? Like, am I really going to be walking away from the machine, or am I just going to be stuck there making sure it doesn't crash? And then all the questions about just integration. Like, I had never really done automation of this type, and so definitely a lot of question marks there. And then the last piece was, if it was just for op 1, what are we doing for op 2? So we thought we'd give it a look. Turns out the hardware for it, and then of course there's the option of getting a full-on robot. So the stuff you need for implementing a spindle gripper is a gripper to go in the tool changer, and then a pneumatic vise, and then some sort of tray to hold your stock.
Who makes
And
the gripper and the vise that you're using?
yeah, so we're running all Shunk products. They've been really good. and no complaints there except the cost. That said, like the whole system came in under 10K for us. So it's pretty approachable. And then the real deciding factor there for me was I was worried that, like, looking around, it's like, okay, why aren't people doing this? Like, if it's such a home run, why aren't we seeing tons of people running these setups? And so I thought like I might implement it and then end up needing a robot, right? Where it's like, okay, this just doesn't do the thing we need it to do, and we're not getting long enough walkway time. So what really pushed me over the edge are two things. One, I actually got some sample code from Yamazen. They sent me some things they had implemented on other machines, and it's just like it's so simple. So basically, you'll have like a master program that is going to call a bunch of sub programs, and it's literally, I mean, it's all handwritten code, but you basically tell the machine the XY coordinate of the first piece of stock, you tell it the spacing to the next piece of stock in X, and then you tell it the last position in X on each row. And when it exceeds, and so you're just incrementing a macro variable for your X spacing. And then when that macro variable is larger than your last position in X, it increments the Y and resets the X, right? And so you're just marching down these rows in the tray. So that's sort of the macro for tray position, like where your stock is going to be picked up. Your vice never changes position, so you're basically calling a sub program to pull apart from the tray. You're calling a sub program to load apart to the vice, and then a sub, you're calling your main program to do your op one, and then you're calling uh, a program. Well, originally we were running op one and then manually flipping to op two. So you're pulling the piece from the vice. So that's a sub program. You're dropping it in a bin and then you're repeating that. And then you're going on to your op twos, which is also a tray with pockets cut out for the contours of op two. We've now added a flip station. So that's another just a sub program. So between op one and op two, it's calling a sub program, pulls the parts from the vice, goes over to the flip station, and you can see this all on our Instagram. There's some footage of all this stuff. It's austere_manufacturing. And yeah, I mean, that's kind of it. So after seeing how simple the code was, the only piece was like, is this going to be successful for our product? Or are we just going to kind of sink some time into it and then realize we should have just gotten a robot like everyone else seems to do? Um, and so the deciding factor there was just like, it turns out if you buy a robot, you don't just need a robot. You also need a pneumatic vise and you need end effectors, which are grippers, which are made by Shunk. Like that's what most people are using. So if we did want to go to a robot, we could literally just take that. Like it wasn't sunk, right? It wasn't like, okay, we're in 10K and now we have to throw all this stuff away if we buy a robot. It was like an investment in the direction we had to move anyway if we wanted to do a robot.
Yeah, totally. And you got the whole system for, less than even a used UR would be.
Yeah, exactly. Right. Yeah, I mean, robots aren't cheap. I mean, they're cheap once you consider what they're going to do for you, but making them do that is not non-trivial.
So about
Yeah.
the spindle gripper itself, Possum Solutions asked, is it through spindle air or coolant driven?
Yeah, so through spindle air, you can also use through spindle coolant. My understanding is that the through spindle coolant takes a little bit to come up to pressure. And so through spindle air is a little bit faster. We don't have the pumps on our machine for through spindle coolant anyway. But you can also run both. So you can run like check valves and run air when you're using the spindle gripper. And then won't mess up your through spindle coolant when you want to drill something.
And then he also was asking about fail-safe systems, so it won't crash. So let's get into kind of because I think that like, and I've talked about this a lot on the podcast. It's not the initial automation that's usually the problem. It is all of the little things you didn't think of, and
Yes.
like automation teaches you where to find all of the little faults. So maybe let's talk about faults you've had and how you've recovered from them and fixed them, and what kind of
Sure.
error checking you've ended up at.
Yeah, so I mean, definitely a puzzle. I think so. I did some work in aviation, and there's this concept of like don't test new on new. There's like so much risk aversion, which at the time you kind of roll your eyes at a bit. It's like, okay, what's the big deal? I'm changing the vendor for for my bolt, right? Like, why is this a big deal? And I think like working in automation has sort of shown me why it's a big deal to change anything, because you sort of forget all the assumptions that are kind of built on that one thing. So um, as a program progresses, I think I've started thinking about it as sort of building up uncertainty, because the operator standing in front of a machine, humans have like amazing vision systems built in. Our eyeballs and just like the processing behind that is like pretty amazing. Um, and and you kind of take that for granted. And so as a program is progressing, it's interesting to think through, what does the machine actually know? And as you have more time between checks, that becomes greater and greater. So errors we've had, I mean, stupid stuff like I moved when we were running when we were running some parts on the gripper and some parts on the tombstones. I had to turn on and off the limits on the fourth axis, and I forgot to turn them back on, and so it just spun and spun until the airlines were completely, crimped.
Oh
Um,
no.
and then, uh, so when the gripper came to pull the part from the vise, it could not pull it from the vise, and the gripper did not know that. And it went and got another part, and then just like rapid in Z, a new block right on top of the old block.
I remember
Um,
you sharing that. Yeah, that looked very
yeah,
dicey.
yeah. And then I came in and like saw that, and then I, put it in manual mode and jogged the Z axis up, and you can watch the whole sort of vice assembly kind of spring back up visually.
Ooh.
Like you can see it. And I was like, man, that is not good at all. Um, and yeah, I mean, those fourth axis on the brother machines are I mean, I don't have experience with other ones, so I don't know that they're more robust, but they are very robust. Um, so we've had really no issues. I actually went right back to zero and it sprung back. And
No way. That's
yeah,
awesome.
yeah. So got lucky on that. And so now we do basically, between every part, we flip the vise over, while so also unloading, flip the vise over. So if the gripper didn't manage to unload it, it would fall out. That doesn't fix the failure mode we saw there, right? I just forgot to turn on the limits. Um, Now we run everything on the gripper, so that's no longer an issue. And we 3D printed a tag that clips onto the handle of the CNC. So if we ever do need to do like a job shop something or other, or prototyping, and we do need to flip it all the way over, it's just a physical reminder to reset, to turn those limits back on. Um, and at the time when we were running tombstones and the gripper, we made a tag that clipped onto the studs of the vise. It's on a lang on the fourth. So
Mhm.
if you pulled the vise and turned off the limits, it was a physical obstruction. So you couldn't reinstall the vise without pulling this tag and, turning those back on. So that fixed that issue. So what we've settled on now, and it's kind of, I don't know that it's the end state for sure, but we do a tool check basically at every tool. And when we're roughing, if the rougher breaks and then steps down such that the tool holder would hit the material if the rougher broke in the first pass, that's no good. So we try to make sure that, um, like, we'd break that into two tool paths and do a tool check between the two, such that if it broken in, taking off the top of the stock and then it steps down to do another run, we want to make sure the tool removed all that material, and we're not going to wreck the spindle. Um,
Right.
I will say all of this is made easier by the fact that our parts are really small. So like we do throw parts every now and then. And we've come up with we took a tool holder and basically jammed it's like a 3/8 side lock tool holder. We stuck a 1/4 inch hose through the middle, and then like um stuck that through another tube so it locks in the 3/8 hole. And so that's like a blow off tool we use. And then we jammed a half-inch compressor hose, like a short section, like 5 inches of compressor hose over the outside. And so that's like just a springy thing we can tool change to. And so we'll come in and push our parts down into the vise with that. Um, it's just like
Oh,
a
cool. That's smart.
compliant. Yeah, I mean, it was just quick. It would be nice to eliminate the need for that tool change, but it works.
Yeah. Well, I know Pause makes a it's kinda like one of those auto center punches, but it's got a
mhm.
big face to use to seat parts in automation, but it's expensive, so it's nice to hear that you came up with one
Yeah,
homebrew that sounds like it's pretty cheap too.
very cheap. We were getting about a 10% reject rate on one part that wasn't quite seated in op 2, and that was pretty frustrating. And so I was on McMaster trying to I was thinking about mounting a pneumatic piston to the side. There's like some bolts up on the side of the spindle housing in the Speedio. So like threaded holes on the side of that, and
Mhm.
some clearance in the sheet metal. So I was thinking about putting a piston in there that I would just fire, like I'd move over so it was right above the vise, and I'd fire that to push parts down. And then I'm like halfway through building out this thing, and it was like a couple $100, and it wasn't going to be here for like a few days. And then I'd have to reprogram everything. And then I was like, wait a second, I think I could just solve this problem right now. Um, and I thought it would sort of be just a temporary fix, but it's worked great. It's both our blow off tool, so we can blow out the vise between ops and push down op 2 parts. Um, yeah, so that's been working really well. So I mean, basically, it's just tool break detect that we use. And my thought is this: if the part is misloaded or anything like that, it will break the tool very likely. Um, a lot of those tools are really cheap. I mean, our roughing mill is like $50, so that's no fun to break. And actually, I have no idea why, but broke last night. Um, and I really have no idea what did it because there's no part in the vise.
Oh, bummer.
So, but there's no damage to anything. So I like kind of scratching my head. I was thinking it might have ripped the part out of the vise and thrown it. But it would have been on an op 2. Um, I think. Anyway, it's a little confusing because yeah, you're not there to watch it, and
Right.
but there's no
So,
damage
back to
anywhere. I
that
can.
first error, though, that you had where you loaded on top of another part, are you now probing for a part there before you load another part to make sure that it's gone?
I am not, because probing takes a while, and we haven't seen that issue ever. Like, it's not happened again.
Okay.
Um, so yeah, and then with all these failures, I mean, I would just say, like, I just posted something this morning, on Instagram about like an issue we had. We're not at the mill to see what happened. It broke the roughing mill. Um, and we do throw parts occasionally, but like all of it just pales in comparison to how much it's transformed our business. So like having an operator standing in front of the machine to do all this stuff, it's not a fun job just loading tombstones all day, or fixtures. Like it's kind of a bummer. And yeah,
I
I
think
mean
you
it,
probably just had a lot of people shaking their heads, yeah.
yeah, like
It is not fun.
no one wants to do it. So, not that you can't find people for sure, but like this thing just runs almost all the time. Yeah, and like I don't worry about it. I load it up and I go on bike rides, I go to lunch, I go do other stuff around the shop, and I'm sure at some point that there will be a big problem, but even if I had to replace the spindle, I mean I'd still be so far ahead cost wise.
Right. So
So
what's the longest run you've had? Paul Alfaro asked that.
so that's something we're still kind of scratching our heads on. Our longest run is about 2 hours at the moment, and we can quadruple that fairly easily to get to 8 hours. But it starts to 8 hours of bad parts is kind of a bummer. So we're just spending a little bit more time thinking about like what do we want to implement before doing that. Surface finish is sort of a hard thing to inspect for. Um, I don't know. So
Do you
we've
find
had
surface finish degradations over the
yeah,
run of
so
a part?
an issue we've been having, and there's a pretty simple fix, I think. is we're running aluminum jaws and we're running aluminum parts. And once you get to like 3 to 5,000 parts through a set of soft jaws, you know, you can tell, right? Like there's a
Right.
little bit of wear on every part, but it's cumulative on the soft jaws. So, um, yeah, stuff starts to drift. The faces start to get marred or damaged if something gets misloaded. And so, yeah, that's been a bit of an issue. So we sort of have two paths forward on that. One is, and this is, I think, the way we're leaning is basically Kanban our soft jaws. So we always have a backup set. So it never interrupts our, right now, if something goes way out or something gets really damaged, it really kind of messes up our day. Because instead of producing the parts we were expecting to produce that day, we sort of have to stop what we're doing and try to fix it or make a new set of soft jaws. Another huge advantage of this automation is even if we do have to make another set of soft jaws, it is not a big deal. Whereas making a new tombstone is kind of a big deal. It's one position, it's really fast. Yeah, but,
Right. Yeah,
but
that makes sense.
yeah, so that's one fix. The other is to do steel. The downside of steel for us is our machine is tooled up for aluminum. It's all standardized tooling. We never really have to touch it. And so pulling all those tools or, pulling 3 or 5 of them, whatever we need to make those soft jaws, just seems like a little bit annoying. And then it increases the barrier to doing any design changes, which is never really a good thing in terms of making sure, just increasing the friction of making improvements is is bad. Um,
Right.
so
Yeah.
and then the last
Well,
piece we've been playing with a little bit, which kind of surprised us, 3D printed gripper fingers.
oh,
And
cool.
yeah, so I was kind of holding off on that. I was looking at all these really expensive 3D printers with carbon fiber and all that stuff. And then one day I was like, I'm just going to 3D print some and see how it does. We ran 650 parts with a set of gripper fingers, 3D printed, no issues, don't see any major wear or anything. So we might just, all our gripper fingers might just end up 3D printed and always just have a backup set sitting there. So if I was doing that, I might add like a tool break detect move for the gripper fingers every like 10th part or something, or every part. I mean, they're so fast on the Speedio. But yeah, again, just really didn't have any problems with it. So, and it's kind of a nice failure point, right? Like if we did drive our Z down with a part in it, like that would the plastic would just deform and kind of give us a bit of a cushion. So, that could be a nice uh, side effect.
Yeah. Yeah, for sure. A little mechanical fuse.
Exactly.
Well, let's talk about your flip station too, because that's a fairly, at least compared to the gripper workflow, that's a new development. And so, what made you guys think of a flip station, and how did the integration of that go?
Yeah, so the flip station, I mean, as I mentioned, like we were running a tray where half the tray was op one positions and then half the tray was machined for the geometry of our op one part. So you could flip it over into these pockets and it would be located properly. Um, that worked. It was annoying to have to flip the part. Also, it meant we had always half of those parts just work in process, right? They weren't finished. Um, so we'd run, whatever 40 op 1 parts and then 40 op 2 parts, but we'd still have a new batch of 40 parts that only had op 1 finished. And so those are just sitting there. We have to store them. If there's any defect we discover in machining the op 2 parts, those op 1 parts probably have that in them. And so just moving toward every time the machine runs, we get a completed part out. Just in terms of where we're headed, that's going to be much better. Um, because we can essentially dump those. We have there's something called batch delays in like lean manufacturing. Um, Basically, if you have a batch of 100 parts, when you pick up the first part, the other 99 bits are waiting, right? And then you pick up the second part, and the other 98 pieces are waiting, and 97, 96, and so on. And then on the flip side, you've finished processing a part, and you drop it in a bin, and now it's waiting while you process the other 99, and then the second part is waiting while you do 98. And so there's major delays, so you can actually decrease your lead times by like I forget exactly, it's like 80 or 90% if you eliminate batch delays, um, or if you cut your batch sizes by a factor of 10. And so we haven't done that in terms of getting them out of the machine one at a time, but the first step in that is producing them one at a time. So just a lot of benefits. And then, another substantial benefit is manually flipping them into those op2 pockets is a pain. And then chip contamination on your op2 is sort of a bigger problem. Um, and so, anyway, a flip station just seemed really like the thing to do. Um, and with all this stuff, I think it's sort of easy to sort of throw your hands up and go like, man, this seems complicated. It seems uncertain whether it will work. And so I'm just not going to try. Um, I think sort of what I've seen time and time again is like, basically like, if you just think about exactly what needs to happen on a very small scale, if those things, if there's no risk in the individual pieces, like yes, there's integration risk and there's sort of system risk, but in each action, if you can break down all the actions, then I just go through each action, sort of flag the ones that I think are sort of that I suspect might not work, and then come up with a bunch of options for how to solve those problems. And then if I'm confident one of those will work, then I can move ahead, right? It's like, okay, maybe. So my big concern with the flip station is the gripper pulls the part out of the vise, goes over to the flip station, comes down. You now have one gripper holding along the y-axis and one along the x-axis that's closing. Sorry, I got that backwards. The flip station is clamping on the y-axis. The spindle gripper is holding it on the x-axis, and then they close. And so my concern was any misalignment there when one of them opens could drop the part, and we have seen that. And then the bigger concern is, so you let go, you flip the part, you come back down with the gripper, with the spindle gripper. Again, if you're having trouble picturing it, we have videos on our Instagram. And then
And
we
that'll be
try to.
linked in the podcast description.
Oh,
I'll
nice.
definitely send people your way.
Then we try to pick the part from the flip station. And my concern was basically that somewhere in there would be misalignment, but that one gripper would be holding it in position too hard to let the other gripper just slide it. And then when they opened, it wouldn't be, it would fall. So I came up with a bunch of workarounds for that, like if you look at the end of the gripper fingers, if it was a little L such that it could open but still hold the part in the air. I was thinking I could add some compliance by having like a urethane face. But the first thing I tried was the simplest thing, was just like, let's see if it works. And it just worked. So, there was definitely some learning there in terms of it did not work the first time I tried it, but I realized that when you, like, again, going back to like thinking about what the machine knows at any given time, the gripper finger picks up the block of stock, brings it over to the vise, sets it in the vise, and then the vise, the gripper opens and the vise closes. So my vise is actuated along the x-axis of the machine, and so there's some uncertainty where the edges of the blocks are in the y-axis, which is a problem for registration when you are engaging both the edges on the X and the Y in the flip station, like when you're trying to do the flip. And so we just run a little roughing mill along those edges to clean that up. We changed vendors for who was cutting our blanks. We get all our blanks pre-cut, and the first vendor was over, like, hitting the top end of their tolerance, their quoted tolerance, and so all the blocks were oversized in one direction. And then when we changed, Devin is from Lycan Precision is now cutting our stuff, and he's
Nice.
basically right on the money, 5,000 over or whatever. So we had a lot of slop in our trays, and so that was causing an issue. But we basically just brought in those roughing passes to clean up the sides of the top hat or whatever you want to call after op one, and that fixed that problem. So yeah, I mean, it's been like I wasn't really expecting it to work the first try. And there's definitely been some troubleshooting, but again, like all the problems we've had, it just saves so much time. I mean, it saves like 5 minutes per tray at least. Like some of the parts were harder to load into Op 2. It was again, it was one of those tasks like no one wanted to do it. I didn't want to do it. And so the machine just sits, and now like we don't have any work in process. It's been a huge win, and it works extremely reliably. Um, and then when there are problems, like, I spend a couple hours looking at the problem, thinking about different like mitigation strategies, what's going to be best, where's my risk, like what's the failure mode, and yeah, again, like huge advantage that we're running small parts, because if we drop a part, like it's not really going to get caught in the way covers or anything like that. It basically just flushes out the back of the machine. So um, yeah, so I'm not doing. I could do like in process probing to make sure I'm in the right position and all that, but that just adds cycle time and uh, might pay off. But there's also other like part presence detection technologies out there. I've looked at the ones from like, I feel like I've seen them on lathes where it's a little flip down wire kind of thing that just checks presence, right?
Mhm.
It's not precision. So I was thinking I could add that sort of on a post behind the vise so it could flip down and check to make sure my part got unloaded or loaded, or whatever the thing I want to know. I could do
That's
it.
smart. Yeah, I like
Yeah, I
that.
don't know. There's also like air pressure monitoring where you can basically drill little holes in your vise, in your soft jaws, and then when the part is fully seated or present, that hole is blocked off and the pressure rises, and you can feed that back into your IO.
Right,
Um,
right.
but I mean, don't fix unless don't fix unless it's broke. So, um,
Well, so speaking of what's coming up, both Paul Alfaro and Possum Solutions asked, like, what's the next big improvement that you've been scheming about for the spindle gripper workflow?
yeah, so all of this, the flip station, all of it is sort of looking at kind of where are we headed. In general, I mean, this has been really just a big win. I don't know that we need to change anything. Um, the Some of the things I'm interested in trying, I built some hoppers. So the Speedios, you can unbolt the side of the machine cabinet.
Yeah.
So basically, unbolt one of those, make my own insert there, and it would just be a bunch of hoppers in the side, and then the table drives under. You have a little pneumatic piston that brings a tray up under one of those hoppers and pulls apart off the bottom, and then brings it over to the spindle gripper. Um, and that would do a few things. It would basically let us run on a much smaller machine. Like right now, we need to put our parts all on the table. You have chip contamination. But the biggest thing is like if I could buy an S500 or an S300 to make these parts and still get really long run times, that would, be really beneficial. So thinking about doing something like that. In order for that to work, that flip station was essential. So that sort of was another reason to try implementing that. Um, the spindle gripper is so much faster than a robot. Just like if you watch the internal speed, like between parts, it's just really fast. It never really loses registration, God willing, unless like you change your batteries with the power off or something. Um,
Right.
it's just like, yeah, it's been really really good. I don't know why more people aren't running them. Yeah, so yeah, I mean, I guess the question was sort of where we're headed. I think the hoppers are a possibility, but again, like what we're doing now, it just really works. And we can probably get up to around an 8-hour cycle time. So we will need to work on kind of what's next when we look at a new machine. Interestingly, I almost bought a new machine and then realized we didn't need a new machine. We were actually just suffering from overproduction. So we sort of addressed that, which was interesting. And now we don't need a new machine. So,
So
um,
explain that. You were overproducing and thinking you needed a new machine, but cutting back.
yeah. So this
Where
is,
does all that math work out?
yeah, it's sort of counterintuitive. So, I read The Goal and Critical Chain recently. Um, and by the way, very odd choice to write for him to write fiction. I found it very distracting from the point, which was really good. you know, um, the audiobook on Audible has like an essay he wrote and a lecture This is Eliyahu Goldratt, at
Mhm.
the end, like just tacked on for some reason of the goal. And those were like the best part to me. Um, but one of the things is basically like, what is your bottleneck? And then don't search for local optimum elsewhere, right? You should make sure you're optimizing for the bottleneck. So I think the temptation is that when you're standing at the mill, it's sort of like, okay, we have a part set up on the mill, let's run a lot of it, right? So we were running sort of half a day or a whole day on one part. And then the next day, when we had to paint the next batch, we'd go to paint and it would be like, okay, well, we have half the parts we need to paint. So we can't really paint, or there's no point in painting because when they get to the assembly station, we can't ship out half a buckle. Um, and this is not an uncommon problem. I mean, this is the whole reason for shrinking batch size. Um, well, not the whole reason, but a big part of it, right? Like overproduction, you're basically tying up machine time in parts that you can't ship yet. And so it would make a lot of sense to only make one of each part, right? One body, one cam, one pin, one body, one cam, one pin. But if you make a lot, say whatever, 200 or 300 bodies, but then you don't have any cams or pins, like the bodies don't do you any good. And in fact, they've done you harm because they've tied up a lot of your available time on the machine in something that isn't useful at all to you. So there's a temptation to look at it and go like, wow, this is great, I have so many bodies in stock. But I think the costs are a little bit less visible. In the Toyota production system, overproduction is the number one waste, which I didn't really understand for a while. I thought it was mostly to do with quality issues, right? If you have a defect and you keep producing before it reaches the point where you would detect that defect, then that's another big problem with overproduction. But the part I was sort of blind to until recently is, yeah, you basically have a lot of machine time tied up in something you can't ship. And the reason we were doing that is because as the operator, I mean, now other people run the machine too, but as the operator, you have a setup on the machine, like let's let it run, and I don't need to do another, changeover to produce a different part. So now what we've done is we run like Kanban cards on all our stuff. Most of the examples of Kanban you see on the internet, I don't know if they're strictly wrong, but if you read like the Toyota production system, they have 6 rules of Kanban. Um, and basically like nothing should travel in the shop without a Kanban card, which means that if so what we were doing previously, and maybe this was just me misunderstanding how to implement it, we had 4 bins of 32 parts per bin, and we would put our Kanban after the, ahead of 2 bins, so we'd always have 64 parts in stock. And then when we hit that Kanban, we would go produce another batch of 128. Which is a weird way of doing it. I'm not sure why we're. Anyway, so now we have a Kanban in every single bin. So we have 4 bins and we have 4 Kanban cards. And it means that every time we pull a bin of 32 parts, which is the batch size for paint, which is another topic, but every time we pull 32 parts, it triggers a production of just 32 more parts from the mill. And so if I pull 32 bodies and 32 cams for paint, it's going to trigger them in that order. And then if I pull an additional set of bodies and additional set of cams, I'm again triggering it in that order. And what we used to do is go through the bin and sort of see how many we had to produce. And so like it'd be like, oh, well, we have 3 Kanban cards for the cams, so let's just run 3 batches of cams. Now we don't. We'll do 3 changeovers or 4 or 5 changeovers in a day.
Oh,
And
really?
that has totally alleviated our need to buy a second mill. Um, yeah, so our changeovers, we spent a bunch of time getting our changeover time down. So our changeovers are about 3.5 minutes, which is trivial. But as a lazy person myself, like, I don't want to do it, right? Like
Right,
you walk up to the
exactly.
machine, you'd rather just throw more parts in and hit go. So, um, yeah, so now we won't do that. We'll change it over and then change it back, and it's kind of counterintuitive, and it's less efficient in terms of spindle uptime. It's less efficient in terms of operator time, but it is way more efficient in terms of like total ROI in the business. Um, and that is, yeah, I mean, that's what it gets back to. So that's been really interesting and eye-opening to see. And I think it's true for a lot of people, and it's true definitely for us in other areas of the shop that we're sort of now just realizing, like, the cost of overproduction. And it goes beyond that. If I spend half a day machining parts that aren't needed, that is half a day that I have not spent on sales. That is half a day I have not spent on marketing or replying to emails or other things. And in a sense, every single piece of the business should only be done in the amounts that are immediately needed, because any amount beyond that is pulling resources away from something else. And so you now have time invested and tied up in something that you're not going to get benefit from for a while. Um, and so, like, and again, like, basically what it comes down to is anytime you find yourself batch working, it's because your setup times are too high. And so it's worth kind of just taking a good hard look at, like, why am I putting this off? So for example, like, I sit down sometimes, and I'm guilty of this all the time. So, but it's really interesting to think about. I sit down on the computer finally after putting it off for a bit to go through emails and get back to people. And then I'm like, well, while I'm here, let me fire off a whole bunch of sales outgoing, outgoing sales, right?
Right. Yeah,
Or
I'm
let
already at the
me,
computer.
yeah, I'm here. Like, I finally, yeah, whatever. Or let me fire off a whole bunch of outgoing kind of like PR stuff, right? Contact, like, publications and stuff. Um, the problem with that is now I have a whole bunch of time tied up in something that's not going to, like, what I should do instead is send off one outgoing email, then ship, go machine one batch, then paint some, then, like, everything should be happening all the time in even amounts, and the loads across all departments should be sort of even. And so it's really interesting to think about. And sort of
Well,
like, yeah.
so now that we're talking about more big picture stuff, let's get into Ben at Beige Power asked, what are your business constraints? Are you supplier sales limited? Are you going to automate your finishing operations? And do you ever see yourself building a replica cell in a second Speedio? So now that we're talking about how you didn't
Yeah.
need a second machine, what will signal to you that you need a second Speedio or a second machine? And then let's get
Yeah.
into your, overall business constraints and, supplier sales limited.
Sure. So I would say at the moment we're sales limited. It's basically the team is me full time or more than full time, and then two part time people. I'm currently bringing on someone who hopefully will turn into full time. I think he's meant to start this week, but was sick, so that'll be next week. I don't think we're too far away from needing a second machine, especially once that machine, the one we have right now, is sort of tied up on production with other people running it. We'll need something for kind of R&D, and then also, like, we are pretty close to maxed out on capacity unless we start running overnight. So that's, I mean, they're going to be a big push is to push a lot of our production to overnight runs, and that's an interesting challenge.
So what does that look like for you guys? Is that, like you said, a smaller machine if you can get these hoppers to work? Is that a different machine because you
It's
have different needs?
probably going to be an R450, so a pallet changer. Um, and the reason for that is, and not a done deal, but, like, I could also get a S500 with those hoppers. The temptation with an R450 is, in the short term, you can put your vice and flip station on one table and then all your stock on the other table. Um,
Right. So it solves that contamination issue right off the bat.
Yeah, and you can reload it while the machine is running, and, like, just some marginal gains. The long-term play there is bar feeding, because that's a traveling head mill, so you can bar feed right onto the table. Um, and that just seems like kind of a no-brainer. At IMTS this year, I asked Williman if they would make a machine without glass scales, or I don't want to pay for a Williman, but I want a Williman, right?
Right.
I
Right.
don't
Right.
need
Right.
that
Yeah.
precision. So they said no. I think that's sort of a missed opportunity for someone, in my opinion, is like, people talk about live tool lathes, live tool Y-axis lathes as sort of like, Jay Pearson was just on, talking about like non-criminal way of printing money.
Right.
Um, they're not really, I mean, not to say people don't make amazing parts and, make a lot of money with those machines, but it's really optimized for a very different activity. And there are machines that are damn close, but aren't bar fed. And so, I just wish someone would do a sort of every man's Williman, the common man's Williman. No, I don't need crazy precision. I don't need a crazy fast spindle. Not that I wouldn't say no to a fast spindle, but I'm not sure I want to pay for it. But yeah, that's sort of the end goal would be a DIY Williman, sort of. And it's not inconceivable, right? You bar feed onto the table, and you don't even necessarily need a bar feeder. I think you could even um, anyway, there's a bunch of contraptions I've sort of thought up because I'm not spinning the part. So the big thing with a bar feeder is it needs to both advance your stock and needs to, add bars. I mean, they're doing a lot of cool stuff, but it also needs to spin at whatever your spindle speed is. So
Right. Well, I know that they did do a bar fed
yeah,
R450
yeah, I
for a
definitely wouldn't be the
customer, a
first.
turnkey. Yeah.
Yeah, yeah,
So that's totally
and that's
possible.
right, totally possible. And I didn't come up with that idea. That was Andy at Yamazin told me I should do it, so I kind of looked at it, and I think that makes a ton of sense. Like, I don't really want to pay for the parts to be cut up. I don't really want to handle each one of those parts, so you can fix that a few ways. Like, I've thought about putting an auto saw. I mean, another option that I am looking at is like an auto saw right next to the machine, with a robot that so it cuts one part and then loads it into the machine. And that would get pretty close too. And you wouldn't be tying up an expensive spindle for parting off the part. Anyway, but it starts to get complicated. It starts to move away from being turnkey. But it get, I don't, I think it's worth exploring all these ideas because, like, the latest one I had, which I'm still a little bit intrigued about, is if I jog my machine all the way to the left in X, um, the fourth axis sort of lines up with the sheet metal at the back of the machine.
Mhm.
So I was sort of thinking if I punched a hole in the back of the machine there and had chutes that were sort of down at 45 degrees with stock that slid down those, I think I could just drive the fourth axis over to a chute, close the vise on the end of a piece of stock, flip it up, and go machine it. Like, for crash prevention, I think you might want a little pneumatic piston that sort of moves those chutes, 3 inches into the work envelope and back out or something like that. But, that's another option. Anyway, there's a lot of cool things you could kind of do. So I think we will replicate it in terms of using a spindle gripper. I think there's ways of improving the efficiency of just like the less I need to touch or anyone needs to touch the aluminum before we get a finished part, the better. Um, so yeah, that's kind of what I'm thinking about. In terms of growing it, probably essentially copy and paste as the first step. So get a machine where spindle gripper, flip station, but I definitely have some ideas for improving it further. So
That's awesome. Yeah, that could be really cool. And I guess with like an R450, that might even be better for the side feed stock kind of thing because like you could just drop it down and then have the spindle gripper pick it up from the edge of the machine, and then
true, right, right. That's a very good point.
Okay. Well, then let's kind of talk about finishing because I think that that's kind of the unsung hero of a lot of businesses. We all think the machining is very cool, and it is, but if you
Yeah.
make more parts than you can finish, you're kind of SOL. So, Bennett Beige Power was asking, are you going to automate your finishing operations? You just got this new blaster.
Hmm.
Paul and AJ at Design the Everything both wanted to know kind of how you're liking it, what the cost was involved with it. What is that true automation? What's going on there? So let's talk about finishing.
Yeah. So I guess like Toyota thinks about automation, or they write about automation anyway, in 3 steps. Probably going to get the names wrong, but the important part is the first stage is basically a machine that will run itself. But the problem with that is it doesn't detect when conditions are out of normal. And so it won't stop. And so it's really important to have a method of stopping production if you are producing defects. And they call that, I think, automation. And then true automation is, instead of stopping, it can fix the problem and get back to production. And basically, what you want to do is get to stage 2, where at least it won't produce bad parts. And this is one of Shigeo Shingo's books. He was saying that basically in that stage 2, it typically represents about 90% of the gains at 10% of the cost. Um, so that's sort of the sweet spot. I bring that up because automating finishing, that's a real challenge, is like surface inspection after painting the parts. That's definitely something I can overcome. Whether that's presenting it to some cameras and then sending photos to an operator at our assembly area to okay them between orders or something. There's definitely solutions there. There's software solutions. I definitely am going to be calling Keyence and some other folks to see what exists. And
That
this
was
is
just
not,
about what I was gonna ask you about, because I know that they have a lot of, Keyence and, I'm blanking on the other name that's big in
yeah,
it, but
same.
a lot of them have part rejection cameras where, you teach them
Yeah.
what a good part looks like, and then you teach them what a defect looks like, and they're just constantly scanning for it.
Yeah, so that will definitely be part of it. In terms of the sandblasting, I posted something about that sandblaster, and if you look at the comments, there's a bunch of folks who have them or have used them who basically they will take your very nice parts and ding them up and scratch them. So that's definitely not what we want. I have not seen that yet, but I turned the pressure down.
So what did you
And
buy, and what did that cost?
Yeah, so it's a Trinco tumble blaster. I forget the exact model name. It's their smallest one. We make really small parts, which is nice.
And so
Cost, I
for
think
those who might not
shipped.
know, it's like a normal bead blaster, sandblaster, and then it has a, 45-degree angled drum
Yeah.
inside that spins and lets you just throw parts in there and blast, and, like,
Yeah.
the blaster is already aimed at it?
Right. So it's sort of low RPM, kind of just moves the parts around, and you're sort of counting on random action to just expose all the faces to the blasting. Um, so we were essentially doing that already for almost 2 years now, but manually. So we had a little basket, you couldn't even see the parts, and you were literally just twisting the basket with the nozzle aimed in the end of the basket. And so it was pretty demoralizing. It felt like, one of the 8 lean wastes is wasted human potential. That just felt like peak waste human potential. um so I was thinking about just building one, because if you look at it, I mean, it's pretty damn simple. But we've been using a Harbor Freight blasting cabinet. They're not very, we upgraded the gun, but they're just not good. They leak abrasive, and that just felt really short sighted to have wandering abrasive in a CNC shop. So like we were pretty diligent about like vacuuming it up every day, but that's all waste. That's like non-value add, really silly. So instead of kind of building something, I just felt like it was like 2,500 plus shipping. So I think landed it was a little under 3 grand. And I'd be hard pressed, I think, to kind of build that once valuing time for substantially less or even less. It just seemed like not money I wanted to spend, but kind of the appropriate move there. Um, and yeah, basically I just looked in the end, and like if you turn it way up, the air pressure, it does blow the parts around, especially our cams, which are really small. The bodies are good. And I just spent a little bit of time kind of thinking about like where the air pressure was pushing the parts. And my suspicion is that the percent, like the, I forget what it's called, but like mesh, you can rate it by like open space, right?
Mhm.
um and so I think the open space is just a little low on the baskets they ship, such that air kind of gets trapped between the part and the basket a little bit. So I think that could alleviate some of the problems, but again, we've been doing this for like almost 2 years without issues of denting. I shouldn't say that. At the beginning they were denting, and we sort of like refined our technique a little bit. And so anyway, basically my thought was like I heard from um a few folks online that like they had them and they were Akluma particularly. He was like, yeah, they dent our parts, so that's a thing, you know. But my feeling was like those are problems I think we can solve, and I think we have to solve. So I just went ahead and bought it, and I expect we'll do some modifications to it. You know, whether that's making our own baskets. I mean, really, the whole machine I'd love to rebuild. Like it came from the factory. Um, with all the pneumatic fittings, they didn't have any pipe dope or tape, and they're just like really cranked down. And I was like, oh man, I did not know. Like I thought you needed tape, but like clearly. So then I connected it to air, and everything leaked. So you do need tape. um,
Oh, man.
so I
That's
took it all
frustrating.
apart and taped everything, and that's a lot better now. You know, it doesn't leak, but it's a pretty crude machine. I mean, it's well built. Like it's heavy materials, whatever, you know, so that's something, but it's annoying to get the basket in and out. You know, just like simple mods would be adding a pneumatic piston that's hooked up to the same air valve to push the nozzle into the basket and then retract it fully so you can get the basket out more easily. The basket mount is like kind of a hot mess in turn. Like it's just hard to get the basket in and out. So, and that's like the main interaction you have with the machine. So like they clearly didn't put a ton of time into thinking about like how this fits into production. Um, you know, I have a machine in my head that would be eventually maybe we'll build it, but basically where you could queue up a bunch of baskets and it would just, you know, pull the next one in, blast it, push it out. And that would be ideal because this only runs for like 5 to 10 minutes, and then you have to change what's in the basket. And that's, you know, kind of silly work when you could just queue it up and let it run. Um, but it's a huge step forward, a really big upgrade. And yeah, I think we can solve all the problems that we were kind of experiencing with it. Um,
And it does a
we
good enough job getting into, tight corners and stuff just
Yeah,
by
yeah.
random action?
Yeah, it's actually better than the manual because our other basket was just a lot smaller, and so some of our parts would kind of, you know, like we'd have to reprocess them. So this really gets all sides so far. You know, we've been doing nearly 100% inspection on the stuff coming out of that just to make sure we don't make defects, and while we're sort of getting used to the new system, and it looks really good. It looks better than what we've had, and so yeah, I have thought about, seeing as we've turned down the air pressure a bit. I don't know if this is how it works, but I was thinking maybe a coarser blasting media would, like would the result would be sort of a similar inertia as each particle kind of hits the surface. I don't know if that's exactly how that works, but I figure lower velocity, higher mass would probably do a similar thing. But again, like it looks good. Like maybe we have to change the media a little more frequently, so we're cutting with sharper media. I'm not sure, but um, and then on paint, like so for spraying our paint, that's definitely something we want to automate, and we're taking steps in that direction. But you know, it's going to be, I think, pretty challenging.
Yeah, yeah, painting's difficult as it is even with, like you said, a great vision system like the human eye, and I can only
Yeah,
imagine having to automate that.
yeah. So actually, I've done some tests. So if you look up like a spin coating line, you can just kind of count on like random action to get all surfaces, and it does a pretty good job. Where basically you spin your part in one axis, and then you have your paint spraying in from different angles toward that spinning part.
So I
Avail
forget, are you Cerakoting or is
Yeah,
it powder coat?
yes, it's all Cerakote.
Okay.
Which really nice results, really not nice process. Wet paint is a bummer. If you can avoid it, avoid it. You know, I think we will do some powder coat. The thing is the anyway, the colors are really nice with Cerakote. The thickness of the coating is um, hard to replicate in something that's like durable, nice colors, and UV stable. So you know, anodize is also a really really good option, and we may do that. I've sort of been saying that for years though. So I was looking at bringing that in house, but like the corrosive gases coming off of it, not something I want in our small space next to our CNC. But I just don't love the large batch sizes required to work with like outside vendors. we've
It's also
had
not nearly as UV stable as what you're using.
Yeah, yeah. So there's sort of downsides, and we'll see. But basically, a spin coating line is really big. We have a really small shop, and it's sort of predicated on setting it up to paint one part and then running a lot of that part. So that's really not how we want to do it. But the principles that make it work. So I took a drill and stuck a racking wire in the chuck and basically replicated the action of a spin coating line and got really good consistent results. Um, just sort of doing it mechanistically. So that's kind of like how I approach all the automation stuff. Like our is just breaking down the actions and just figuring out if I can crack each one and make it like as close to deterministic and like fully constrained as I can. Um, so like our assembly process, we used to do it in a highly manual way. I sort of designed a fixture that are all simple mechanical actions. And so the next step there is just to like, actuate those motions, probably pneumatic cylinders. Um, but yeah, so the spin coating line, I think that method works. And so I think we're going to sort of try to use a robot to basically present each part to spin each part, present it to a paint gun and do it that way. And the benefit there is we're not sloshing the paint around by swinging the paint on the end of a robot. We don't need to add some of the fancier, there are paint systems that are designed to go on robots, which have long tubes and pressurized pots. But that means you have more paint waste and, changing colors seems like a pain. And so I think we could present it to the other nice thing about this is we could have a bunch of paint guns next to each other with different colors and just alternate. We could paint one black, one whatever, orange, one blue, and alternate that to match the load at the assembly station. And yeah, so moving away from batches and toward single piece flow, even through our paint, we could cut our throughput by like 3 hours. Um, our lead times through the paint department by 3 hours if we moved away from batching.
That'd be
Um,
killer.
yeah, so definitely taking steps there, but nothing quite yet. But stay tuned.
So Ben at Fort Manufacturing from the Patreon asked, "What kind of end of year review do you do? How about your process for projecting and goals for the next year?"
Yeah, I'm not a big like New Year's resolutions guy. I definitely end of year kind of looked at where we're at, where I was hoping we would be. Look at revenue and costs and kind of all that. And then spend a bit of time thinking through kind of where we're headed, where I'd like to be in the next 12 months, kind of what stretch goals would be, and then kind of working backwards toward, what decisions do we need to make now to kind of at least put ourselves in the position to hit those targets. Yeah, I mean that's kind of my process. I think I kind of do that all the time though, so I don't know. I don't do a major one at the end of the year, but
You just continually looking at and improving your goals or changing them as things come
yeah,
up.
and like looking at what's working for us, what's not working. I think there's a balance between like I recently read through a template for a business plan, like a fully fleshed out business plan, and there's a lot there. It's really useful to think through. Um I think for a big organization that takes a lot of time from the time like goals are set to sort of propagate that down through the whole organization and sort of test that direction. I think you kind of need all that, and I don't want to let myself off the hook in terms of thinking those things through. But as a small team, we can be quite responsive. So I think there's a balance there to make sure we're being proactive and thinking through where we want to end up and not just reacting to what's working. Because like, like the concept of like a hill climbing algorithm or like peak seeking is the big downside if you always tell a robot to move uphill is that it will find a local maximum, but a small little bump on the side of a mountain, it will find the top of that, but can never get to the top. um,
Right.
so I think just zooming out and making sure, um, one thing with our current products is, they're very expensive, rather relative to other hardware, but they're really quite involved to make, and so like just business wise, um, the margin we offer to retailers is nothing they're really yeah, they're not super excited about it, right? And it also precludes us from like working internationally becomes challenging because then you add a dealer, in whatever country, and they get a cut, and there's just not really enough margin to go around on that product, or to get people really excited about it. It's also challenging to sell to bag makers who then sell to retailers who then sell to consumers. So we've had better luck selling to bag makers that go direct. So just learning from that. I mean, it's been a really successful product for us. Demand has definitely exceeded anything we kind of imagined. I actually went and re-listened to our previous, last time I was on the podcast, and uh, it was funny to listen to. I was like, it's super niche. Bike packing is a really small industry, which is kind of what we launched into, and it definitely is, but it sure has kept us busy, and now it's definitely growing into other markets. So,
That's
um,
awesome.
yeah, it's been great. But definitely thinking about like what products to do next. Hopefully we'll learn from our mistakes. Not that they're bad
So,
mistakes, but just
so I want to get into new products, but first up, Molly No wanted to talk about the bar tacker and what it's like to program a sewing machine.
Yeah, the bar tacker. We are running programs that came on it. Which is basically, I don't know if it's strictly laziness. I'm not a huge fan of the way that industry works. It makes sense the way it works, but basically, those machines are designed for massive production. That's most of their customers are, really big cut and sew shops. Um, who basically set up a line to run a particular product or reshuffle a line, but there's a lot involved in sort of getting a new line running. And it's a cut and sew shop. They're not a machining shop. A lot of them will have really capable mechanics on hand. And I've seen some really ingenious, homebrew, fixturing for tacking. So when you bar tack, you need to fixture the fabric, which is, uh, designing good fixturing for like CNC mills is tricky. But at least the thing you're holding on to, with exceptions of like super thin wall stuff, but at least it sort of stays in the same place, right? It's
Right.
rigid.
Yeah. There's something to grab there.
Yeah, exactly. The fabric is tricky and sort of takes a lot of feel and sort of like, I don't know, guess and check or experience or something. And yeah, so you basically send a sample of what you're trying to do to a shop is the current model, and then they'll build you custom fixtures for it and write a program for it. We haven't done that because I'd rather just, I don't know, maybe this is a mistake, but just do it in house. Like they charge thousands of dollars to do that. And we have a CNC, and send cut send is a thing, and so we're probably just gonna do that. That said, like they charge like I think it's like $750 from Juki to get the program to write a new program for that machine. Um,
Of course.
and when you open the software, you're like, wow, this is this
Yeah.
is ancient.
I'm
um,
sure.
yeah, it's pretty rudimentary, and I think just generally it's kind of interesting. The old model seems like charge for software with these things, and I mean, obviously, people still charge for software, but like when you're selling a hardware product and that's the product, you're sort of just building up like a barrier to entry, in my opinion. Granted, I don't know what my opinion is worth because I don't run that kind of business, but we've been looking at different robotic arms and like the level of support on YouTube of just like, here's how to program our robot. Like a lot of these legacy companies are like, hey, we offer a 3-day training. And it's like, I don't know that I have 3 days for that, because I could figure it out if you just would show me the stuff, you know? And so I don't know. I think there's sort of an opportunity for a lot of these companies to sort of just make onboarding easy
Yeah,
to like
well, it's like a
jump on
stark
there.
contrast to like UR, where you can just like download a UR controller basically and run
Right.
it in a virtual shell and just like play with it.
Yeah, and that's like a serious temptation. I would say like like when I was shopping for machines originally, I almost got Haas because of the online community. Like anything you want to see like is on YouTube. It's like here's how to do it. Whereas here, like there's an awesome community around the brother Speedios, but it's not something that is really apparent before buying one, right? Like it's something once you get one, like I've reached out to you with questions, reach out to there's plenty of people who are willing to kind of help you out. So,
Right.
but
Well,
you don't
it's
know that.
very
So
user centric. It's not manufacturer centric with a brother, where with Haas
yeah,
it is
yeah.
coming from Haas.
Yeah, and like if you look at a lot of I don't know, a lot of software companies, like they've realized this and give free licenses to students, right? Because it's like once you're comfortable on our platform, you're going to want to stick with it. And so and I think some of these hardware producers are sort of looking at their software maybe as like another thing they can make money from, but really it's just like the big question to me in buying a robotic arm or a sewing machine is sort of like, okay, how am I going to program it? Like I know I can hit go, right? I know I can hit cycle start, but like, yeah. So making that anyway. So yeah, the Juki is a little annoying. I mean, the more expensive this one was like around 7 grand. If you spend like 15 grand on a machine or buy a used one, sort of the next big step up in programmable tacking. Um, those you can program on the like at the machine, and so you don't need to buy more software for it. Um, I'm really curious what the format of this software is. Like if I could just handwrite it, because it just doesn't seem like you're commanding a bunch of sort of, I don't know if this is how it's programmed, but I'd imagine you're programming sort of XY locations and sort of feeds and speeds essentially. So
Right. Yeah.
one would assume.
Uh, let's see. Thomas D asked, as a product designer, what other products do you look at in the world and say, "Oh yeah, that's just right"?
That's a good question. Let's see. I guess one that really comes to mind I was using yesterday is like the Nipex plier wrench. Um, you know, that
Hmm.
thing just
Oh yeah, that thing's
does a great
awesome.
job. Love that. Um, I don't know. I mean, I think like I don't know if anything's quite that simple. Like I've definitely gotten a lot of really positive feedback from people who buy the buckles, but like the reality is, they're more expensive than other buckles you can buy. So I think it sort of depends what you're optimizing for. Like others that come to mind would be like a lot of the Shunk products we've bought, like the machining and the tolerances are really, really good. The surface finishes are pretty damn impressive. But you pay for it. So I don't know, like, are you looking yeah, it depends what you're optimizing for. Are you looking for like that sweet spot of value? Are you looking for just like, out and out kind of quality? Um, yeah,
Also,
I
like,
mean,
what other things have you encountered where just the design? I mean, taking money out of it, but just the
right.
design is very gratifying to use or to look at.
I mean, I definitely like the Michutoyo stuff. That like their new, some of their new micrometers are definitely nice. Trying to think. I'll have to think about that. Maybe something will pop into my head.
All right. Well, so I saved 3 questions for what's new because Ben at Fort Manufacturing and Joe at Cobra Frame Building both were asking about new products in 2023. Are there belt buckles? Where do you go next from straps and buckles? And Debris Brooms was asking, has the automation effort that you've done on your current product slowed the production of another or the development of another? And so kind of what's new in your world? What
Yeah.
is going to be coming?
So I have a bunch of 3D printed buckles of different designs. I definitely want to be totally excited about what we're putting out, and a lot of them have a lot of promise, but just need kind of, they're just not there. So again, in listening to our previous episode, just trying to remember what we covered, um, it was a little embarrassing in that, I remember at the time I had some other products that I was like, I think this is really, I think we'll be out with this pretty soon. But none of that has kind of made it to market yet. So we'll get there. A lot of people have been asking for a belt. In fact, Cobra Frame Building specifically asked about a belt. Yeah, a belt is coming. I don't know exactly what the interaction will be in terms of the buckle. And I have a few that are nice in different ways. In terms of automation, so actually it's funny, the a big reason for doing for moving in the direction of this system is actually ease of implementing a new product. So it actually makes it way easier because a tombstone or some large fixture, like, they take quite a while to design, and you have a lot invested in that in terms of clamping. It takes also you're sort of like you're often trading off density for tool access and just like other trade-offs that are hard to uh it's hard to know as you're prototyping whether you're going to be able to produce it effectively, whereas with our setup, yeah, it's super super simple. We can make a set of soft jaws in, like, I don't know, an hour, and be running parts on that just manually loaded. And then if we are happy with the design, adapting an existing gripper program to run a new part, takes half an hour, 40 minutes, something like that, maybe less. I mean, they're really quite simple. I say half an hour because it probably takes like 10 minutes to reprogram. But then you kind of just want to watch it, make sure it's loading everything. Inevitably you're going to tweak a little bit of, like, I want the gripper to come down a little further when it's feeding into the vise, or a little less far. Like, I can see that the part is sort of sliding in the fingers of the gripper at the end of the stroke. So I'm just going to reduce that so we don't reduce the wear. Just little things like that. So by the time you're done, it's probably, half an hour to an hour. Um,
That's
but
still
it,
not bad at all.
yeah, it's so fast. And again, that was like a big deciding factor for us. Is like, a big challenge for us is not like, it's not only coming up with nice designs, but it's also making sure that they're highly producible, really manufacturable. And the issue previously was that our prototyping setup was really a far cry from our production setup. And so there were sort of two phases to product development. One was coming up with a product we wanted to make, and then the second really big lift was figuring out how to make it efficiently. And now those are basically it's one and the same. So in prototyping it, we are working out how to make it. And, like, yes, we are going to go through a phase of, like, watching the program run and being like, I think I could, increase the feed here, or remove that linking move, or, there's stuff to clean it up, and there's definitely time savings there. But yeah, it's actually been a real big benefit to producing other stuff. You wouldn't know it because we haven't launched a new product in 2 years, but you know we have run parts for other people, and yeah, it's like, it's just so easy.
That's awesome. So what else is new in your world?
Yeah, been doing a lot of process improvements, lean improvements. Bought a whole bunch of equipment since we were last on. Upgraded the compressor. Got a Kaiser, whatever. Sewing machine. Upgraded the sandblaster. Um, big improvement, actually. So it's funny. I mean, I think, like, there's sort of this thing on the internet or on Instagram where people post about new machine day, or like lean improvement. We bought all new benches. And it's like, you look at that as a small business and it's like, man, that is really expensive. Um, and I think there's just, like, I don't know, like, having a really clean, organized, beautiful shop with all new toys in it is cool. And I think maybe that is where you end up if you keep working at it and make your systems really efficient, and realize that, like, cleanliness does lead to noticing, when your machine is leaking oil, or when when something spills or when other things are going to lead to breakdowns. Um, Reducing visual clutter just makes it easier to um, produce stuff and reduce like ambiguity when you look at a workstation. So maybe the conclusion or where it's headed, but I think like there's so much time to be gained in just small things. So like one of the things we did was put each setup on a separate sheet pan for like baking. You can buy these like speed racks and then all these sheet pans. And so every part has its own sheet pan that has the gripper fingers on it. It has our soft jaws. It has an example part. It has an example of the stock we use to load it. It has the program number listed on it. And it's just been so big for us. And, looking at it the other day, like I probably spend 5 to 10 seconds finding which sheet pan I'm meant to pull. Right. So it's like, okay, 3/4 cam. So like the other day, I was like, okay, I really need to color code these. Right. So like each product, each piece we make has its own color. And so just at a glance, and like I was actually playing with a spreadsheet the other last night on just like how those small improvements build up over time. And it's actually really impactful. And your break even point, like if you spend a full hour on improvements every single day and you're able to save 10 seconds for every team member per day, like you're going to break even by the end of the year, which is crazy. And then by year 3, you've like tripled your, and that's such a conservative goal is like save 10 seconds. Right.
Right.
Um, and that's with spending no money. So like I read another book I was reading. I think it was Toyota Production System. Basically, at Toyota, like if you can spend $500 to reduce the need for one worker on a line, like that would be a huge win. But it is all waste if you can also do the same thing by just like reorganizing your shop a little bit, right? And spend $0.
Right.
So I think that's just worth bearing in mind. Like, I think like color coding stuff is going to maybe be as impactful as spending $3,000 on a sandblaster, right? Like, we had other reasons we kind of made that choice besides just the time savings. Um, but yeah, I think it's easy to kind of look for all the big ways you can change a shop. And I think the more I'm doing this, the more I'm kind of, and I'm not an expert by any means, but like, I think just where I'm at is sort of like looking for those small opportunities to save time. Um, every time you kind of try to plug in a USB cord to a port and you're like bending around to find the port or whatever, or you try to plug it in the wrong way, like that's an opportunity to fix that. And it's cheap, virtually free to fix it. And, you know, anyway, so I think that's like a lot of the stuff that's new in the shop has more to do with that. Like I calculated the volume of our sump on the CNC and just put a note next to it. So you take a reading and the note is basically how much volume of coolant concentrate to add for X% change, right? And so instead of pouring some in, taking another measurement, which is what we were doing, and I'm sure there's better ways of doing it, but now top off the water, take a reading, and then add a certain a couple quarts, and it's just a yogurt container we had laying around. So you just fill that up a couple times, dump it in, and we hit like pretty dead on. It's not
I
perfect,
like
but
that. That's really smart.
yeah, $0 basically. 5 minutes and $0. So I just think there's tons of that. We got a new paint booth. We're building a loft to give ourselves a little more space. I sort of talked about like the refining of our Kanban system, but that's definitely been really interesting to see is like, and something I've been thinking a lot about is like people talk about flow a lot in production, right? Like, parts shouldn't be waiting and they should move from process to process. And sort of been thinking like that is also true with information. And I think we have a lot of information stagnation. So like when we are pulling parts from inventory and you're not triggering any Kanban, that is information that is not traveling upstream. Um, so it's kind of interesting to start thinking about, or like stuff sitting in your inbox, like inbound inquiries, like and again, like just thinking through like how can we make that faster. So for example, I was having this issue where it was taking me a while to send pricing info to customers or to interested customers, and I realized because I was unsure of like it'd take me a bit to find the current version. Like I had it in a separate folder, but every time I'd have to click through. And Google, you can't, or I haven't figured out how to put attachments in an email template. Like every time you have to go reattach them. And
Mhm.
so I just made uh, a Dropbox file, Dropbox folder, and shared a link that is in that email. So now I can, it just shaves, I don't know, maybe a minute off of sending each of those emails, and just reduces the friction such that it's like way faster for me to just sit down and send it. And then also I can always update the PDFs in that folder. And so,
Right.
that's no
No
longer like,
resending anything. Yeah.
yeah, no version control. So anyways, just stuff like that is yeah, a lot of exciting little improvements that really save us a lot of time in the shop.
Yeah, those are a lot of fun. Like little quality of life stuff. It really, I mean, it quality of life's in the name, but like you really feel it. Like you just feel happier working around that kind of stuff.
Yeah, and not only happier. I mean, it's just you're way more productive. Like you're like if you look, so a lot of shops, there's sort of like value add versus non-value add activities in the shop. Um, Value add activities normally account for about 15% of people's time in the shop. So like 85% of the stuff you're doing every day is waste and is not value add. Um, and me too, like everyone pretty much. And that can be sort of demoralizing, but it can also be, it's a huge opportunity to just get that, a little closer to whatever, 50% or 70%. Non-value add, and like just thinking like in our paint process, like every motion that has nothing, that is not the paint landing on our part, is all waste. And some of it is necessary at the moment, but I think it's just worth keeping an eye, like sometimes I'll go through the work and you can just go like non-value add, non-value add, non-value add, okay, value add, right? Non-value add, non-value add, value add. And then it's like sort of like, okay, well, how, like, what are these motions we're doing? um like I timed out walking from our shipping station to our assembly area because sometimes I find myself walking back and forth, and it was about I think it cost me 5 cents per trip basically. um and so then it's like, and so now I keep a note of like why I'm walking there, like what do I need, and then I'll make a note, and then the next day we can kind of look at those notes and say, okay, like how can we fix this? Is there some visual we need to be able to see from the shipping station to know something about, or like from the assembly, like what, how do we mitigate these? And it's so much more pleasant, as you said, like quality of life, but also just like if you ask the customer, hey, do you want me to, can I charge you for walking across the shop to get a screwdriver? They're like, no, thanks.
Right. Yeah. So
Right.
you're just like
So
finding things that you can stock on the other side of the room or something rather than walking back and
yeah,
forth.
yeah, all that. And it just like, yeah, so much more pleasant because you just feel productive instead of like tripping over yourself, and also really a lot more profitable over time. Hopefully.
Yeah. No, that's awesome. Well, that brings me to the last question I ask every guest every week, which is what did you research this week? And it doesn't have to be machining related. It's just, it's always interesting to hear what interesting people are looking into.
um yeah, I guess a few things. I mean, definitely robotic arms has been high on the list, and sort of paint inspection, but I think the biggest one is sort of yeah, refocusing on the opportunities in efficiency on those smaller, with near $0, and just trying to like refocus on those, uh, thinking through how information is flowing through the shop. Um, I've been watching a lot of shop tours, reading another book by Shigeo Shingo. He has a bunch of books, and they're all really interesting, except for one. I'm not loving the sayings of Shigeo Shingo. They're very repetitive, and they've been covered in other books. But I think something I've sort of been taking away from it is just like a super absolutist view of work, which is just like at a fundamental level, are you achieve there's a line in there where he talks about like painting the air, right? Like that is what's happening when you have overspray in a painting process. You are like, that's all waste. It's all bad. And I think like over time you get habituated to how things are and forget to revisit and say like, why are they this way? Can we change that? And so just like seeing what other people are doing in terms of information management, in terms of, yeah, again, just like reducing visual clutter, just trying to, yeah, kind of, that's a lot of what I've been thinking about.
Awesome. Well, one more time, where can everybody find you online?
Yeah, so austere underscore manufacturing on Instagram. Austeremanufacturing.com is our website. Um, Go check it out if you want some fancy cam buckles. Yeah, reach out. Love to hear from folks what's interesting, what they want to see more of, and yeah, what products they want to see next. So drop us a line.
Awesome. Well, thank you so much. Thank you to all the Patreon members who make this show possible. Thanks everyone for listening, and I'll be back next week.